3. Right, so for this demonstration it would be based on a metabolism or respiration lesson. You would ideally set it up at the start because it takes some time to run because we're dealing with yeast. But you might want to first introduce the class to yeast, sort of if you've maybe covered anaerobic respiration in humans or respiration in general. You might want to go through yeast as sort of what they do, where we find them, the morphology behind them. And once you've done that, you can sort of introduce the demonstration. So each of these bottles have, this is the control, this would be a 1% solution of sucrose, and this is a 10% solution of sucrose. In each there is 400 millilitres of water. In this one there's 4 grams of sugar added, and in this one there's 40 grams of sugar added. Okay. They're all distributed using the same water, so we keep the temperature the same. So we made one 1.2 litre solution of roughly 40 degrees Celsius water, and then distributed into each to keep that error low, which you might want to talk about with your students and say, why did we do that, just to get familiarised with that terminology of errors and human errors. Okay, and then so in here we have some just regular old baker's yeast. I'm going to add it to this solution of just tepid water, so again roughly 37 degrees. Okay, we're going to mix that up. Okay, just while that yeast wakes up. Again, you might want to just go over where you might find yeast, some of the applications, what do people know in the class about yeast. You might get some people saying bread. I've used it in baking bread, or used it in people use it in brewing. Okay, this strictly is Saccharomyces cerevisiae, so you might want to start using some scientific terminology as well. Okay, and then you're going to use a syringe or a pipette to distribute the same amount of the yeast solution into each of your bottles. Okay, so I am going to go for 10 millilitres or thereabouts. Okay, and just dexterity. Okay. Ideally, in a school environment, you'd use test tubes in a bit smaller volumes, but for the purpose of this, it works all right. Okay, so then you just give them a swill up. Make sure your lids are on. Okay, and then simply over the top of them, you're going to put a balloon without it falling over. Preferably have dry hands because it makes life a lot easier. Okay, 1 down, 2 to go. Alright, so you'd leave that now till the end of the lesson. Keep these all in the same environment to keep the temperature the same. Make sure you keep your labels to each bottle so you don't mix them up. While that's running, you could get your students to work through your worksheet you've provided them. So to go by some theory behind anaerobic respiration, such as the formula, applications, in this investigation, you might want to see it as an opportunity to go through the variables. What were the variables in the experiment, so the control, the independent, dependent. Some of the questions you might want to ask them. And how could I improve this investigation as well? So it was good to start getting them to think about how they would do it and how better to improve it. But we'll let this sit for 40 minutes or so, and we'll come back and see what we get. Okay, so to finish off, towards the end of the lesson you should get something along these lines. So you've got your control here, 1% solution here, and the 10% solution looking something like this. Before you sort of talk about it, you want to sort of get the students to sort of lead you through it. What do they think? Why is the 10% solution so well inflated? What isn't actually inflating the balloon? What's being produced? You can maybe get into sort of the chemistry behind it. So, the sugar in the sugar carbon's been converted into CO2, and what else might be present in there. So you hopefully get ethanol produced as well. Might give you an opportunity as well to discuss, why it was so important to have the same level of water in each of the bottles. Because the gas pressure would be different if there's 300 millilitres in this bottle and 400 millilitres in this bottle. It's going to take longer for this bottle to inflate the balloon because there's more gas present. Other controlling variables you might want to talk about is also like pH as well. You can investigate that, and you can maybe ask the students to sort of give you how you would investigate the pH, how would be best to go about that. Salt concentration as well, you might want to investigate that. And again, going back to what you could do to improve the experiment, so using better sort of maintenance of the temperature would be good. A way of measuring the actual amount of gas rather than just balloons would be beneficial. Hopefully it just sort of gives them a visual aids to help them go through the experiment, to think about anaerobic respiration. Okay.